Morning. Here we're going to have a look at 2017, question 10, part A. Alright, so this is a nice little bit of a motion question, part A, but there's a little bit of fiddly kind of algebra as we go through it. So, what are we given here? We're given that the product starts from rest and moves in a straight line acceleration to 25 minus 10v. So our acceleration, okay, is 25 minus 10v. And we need to figure this one out, and we want to find out t in terms of v. All right, we're giving a little bit of a note here just to help us out with some of the differentiation. Okay, and we'll work about part 2 afterwards. Well, acceleration is dv dt. It's the rate of change of velocity with respect to time. So we have that one there. So really what we're going to do is we are going to try and take this block here and integrate it. So, quick little bit of rearrangement, our usual bits and pieces on one side. So we end up with dt here equals 1 over 25 minus 10v dv. And you can see, of course, there's a little helpful piece that if we have 1 over a plus bx, which is this setup here. Now, they've given it to us with a constant. You can use a constant, you can use the limits. I'm going to use limits. All right, so we'll just pop our little integration in there. Our limits are, well, it starts from rest. So at time 0, it's not moving. And it's going to end up with t and v. T and v. Okay. There we go. So, well, this one's kind of straightforward. It's just t. And we put our limits in t and 0. Now this one, a little bit funkier. So in our case, b is minus 10, watch that one there, and a is 25. So we have minus 1 over 10, natural log of 25 minus 10v. And our limits here are v and 0. Okay, so just, nothing too bad. They gave it to us there nicely. Main thing is watch your little minus sign. Let's go ahead and bang that out. That is t minus 0 is minus 1 over 10. Minus the 0 one, which is of course minus 1 over 10, natural log of 25 minus 0. Okay, so we'll just go ahead and tidy that all up there. T equals plus 1 over 10 natural log of 25. Now, we want to bring these guys together a little bit here. Essentially, remember, it's really this one, minus that one. All right, so we have log A minus log B. It's log A divided by B. So this is the same thing, it's just a bit uglier. Okay, so it's 1 over 10, because remember, it's this one minus this one. Natural log of 25 over 25 minus 10v. I actually think working with the logs and exponentials in this question is nearly harder than the differentiation and integration. So it's good practice for that kind of thing. Now, okay, we've gotten this far. So how do we begin to actually go any further? If you decide, oh my God, I'm stuck and I'm going to look at the marking scheme, they just magic the answer out of thin air. But there is a little bit of practice to be done in it. All right. Now, what we want to remember here in our side is that if we have natural log of y equals x, then what we then have is y is e to the power of x. Okay, so we have natural log of that bundle of joy equals t. So what we can just do is we can turn this whole thing around and we can say that 25 minus 10v, okay, equals, actually, apologies, I should have really just tidied up a small little step here before I do this. Let's say the natural log of 25 minus 10v equals 10t. Okay, so I'm just taking that 10 over there in one little explicit step. No point in doing too many things at once. We tend to make little slips. Now, we know here, 25 over 25 minus 10v equals e to the power of 10t. Now, you could have cancelled out your 5s and stuff. It's not too, they're only 5, so I have left them in there. It's not too big a deal. All right, now how do we take this guy and extract v? We want v equals something or other. Well, first of all, I'm going to get rid of this, and we're going to try and see what kind of terms we get. So if we come all the way up here, we end up saying 25 equals 25 e to the power of 10t minus 10 e to the power of 10t, 25, oops, apologies, minus 10v e to the power of 10t. Okay, so I now have 3 terms. At this stage I will cancel the 5s because it's just annoying me. 5 e to the power of 10t minus 2 v e to the power of 10t. Okay, I want v equals something, so this v needs to go over here on its own, and that 5 needs to come out of the way. So 2v e to the power of 10t, 5 10t minus 5. Checking our signs, yes, we're all good. Okay, at this stage we just got to chip away, remove all the bits that aren't v. So we'll lose a 2 first. V to the power e to the power, oops, v e to the power of 10t, just watch what's the power of what? 2.5 e to the power of 10t minus 2.5. Alright, now we've got to lose this guy, but actually e to the power of 10t exists in both of these. So what we're going to do is we're going to divide everything by e to the 10t. And it will get slightly prettier at the cost of that. So now what I have is v equals 2.5, okay, minus 2.5 over e to the power of 10t. We can tidy this up a little bit. I wouldn't be leaving it just at this stage, okay? There's 2 key things we can do. Well, v is 2.5, 1 minus 1 over e to the 10t. That's step 1. That's a bit easier to work with. And actually, we'll bring this guy up because basically, if it's 1 over, we can just put a minus sign in. So we say that v is 2.5, 1 minus e to the power of minus 10t. Okay, if that was 1 over e squared, it's e to the power of minus 2. And that's what we're going to do there. Just tidies it up nicely. And there we have a lovely answer to it. Okay, so that is part 1. Now, part 2, I think we're going to have to flip a page. Part 2, we're looking at the time taken to acquire a speed of 2.25 and the distance traveled. So we've really got kind of 2 bits of this one. Let's get a fresh sheet of paper and we'll bring that one back as we need it. Now, first of all, let's get our speed. Well, we know, this one actually is kind of easy. We know that v equals, let me just look back to myself here. V equals, sorry, we're looking for time, apologies. Jumping ahead of myself, time equals something or other. If we come back to this page here, we'll see time equals all of that in terms of v. Okay, we're given v, so this should just fall out. So time equals 1 over 10 natural log of 25, and that's 25 minus 10 by 2.25, isn't it? Yeah, 25. Okay, so what we've just done is subbed in for v. There we go. That's going to pop out for us in a minute. T equals 1 over 10 natural log of 25 all over 25 minus 22.5 is 2.5. Look at this. Aren't they being so nice to us? There's something else sneaking up along the way. And time equals 1 over 10 natural log of 10. So time equals, stick that in your calculator, natural log of 10 divided by 10. Okay, so what I'm going to do with this one is I'm going to store this. So just make sure you know this one. Shift, store into A. All right. 0.23 seconds. If they ask for the time, do give it in seconds or minutes or hours or whatever it is. Okay, next we want to do is find the distance. So this is a little bit more work for us. All right. And as we look here, I have my time equation for time, that was fine. But the other equation I have is for velocity, so that's not much bloody good to me. But what we did is, so find S, we know that velocity is, of course, ds dt, the rate of change of distance over time. So this is how we're going to figure this one out. So that is equal to 2.5, 1 minus e to the minus 10t. Okay, so a little bit of rearrangement, as always. It's actually fairly straightforward to rearrange this guy, because we have just ds equals 2.5, 1 minus e to the minus 10t dt. Now, when we go to integrate this one, I'm going to leave the 2.5 outside because I don't need to deal with it. Just pop it out there. Key is not to forget about it. Don't leave it all lost on its own. And we want to find the distance traveled in this time. So what do we know about our limits that we can put in here? Okay, this is worth just thinking for a little moment. We want to know our distance. Well, at 0, it's 0. Okay, because it started, hadn't moved anywhere when it started. And we know our time there is 0.23. Actually, we even know it's stored in our calculator as A if I want to get more details. Okay, now, a little bit ugly. So since it's so ugly, we're going to come all the way back up here. This side is fairly easy. S, okay, 0. Now, equals 2.5. Pop it outside the brackets. All right. Now, that's just going to be t. And we need to have a little look at what this other one is going to be. Now, if I just actually break off over here, little note, we know that if you integrate ex dx, it's just ex. That's normally nice and easy. But of course, the other one to know is if we integrate aex dx, it becomes 1 over a e to the ax. All right, and that's the little bit we're going to use to make sense of this one. All right, so this becomes minus 10 minus 1 over 10 e to the minus 10t. All right, and our limits on this one, of course, are 0.23 and 0. A little bit of tidying up. S minus 0, 2.5. Now, that is 0.23 plus 1 over 10, we'll deal with it afterwards, e to the power of minus 2.3. And minus 0 plus 1 over 10 e to the 0. Okay, what have we got here? Now let's see how this all comes out. S is, well, 2.5, leave that outside for the moment, and we end up with 0.23 plus, now, e to the power of minus 2.3. Okay, and again, we'll just store that in B. All right, minus 0, clear, and we have e to the power of 0 is, of course, 1. So that's 1 over 10. Okay, in brackets, don't forget your little brackets here. Now, and that is going to end up being 2.5 by, let's just see, we have, now it's lovely, we can do recall A plus recall B. Just must double check, recall B was, of course, yeah, so it's e to the power minus 2.3, so we'll just knock that off. So recall B by 0.1 plus recall A minus 0.1 equals all of that by 2.5 equals, nope, I'm not going to skip the step there, is 0.35 meters. Okay, Just pop that number in there. That's 0.1428. All right, and there we have it. Distance traveled, 0.35 meters. All right, just as a small little aside, if you ever want to double check that and try and see what's going on, think of your velocity speed diagram, 2.25. Okay, that's velocity, that's time, 0.23. Well, the total distance it could have traveled is 2.25 by 0.23. So let's just clear that. Okay, which is, so the max is 0.52. Okay, which means, and again, the half of that is about 0.25. So you can see we're looking for something kind of between 0.25 and 0.52, and that's a nice way to double check our answer is on the right track.